All right, we're going to try to see if we can calculate the principal unit tangent vector. So if a vector is at the initial point of the vector moves off tangent to whatever curve it is, and you can see here in a little figure 3.5, the initial point of the vector is right there, and then that vector moves off in a tangent way tangent to that circle. So the initial point is touching the circle, and that is the only point that's doing it. It's moving off in a method tangent to that. So to find that tangent vector, we use this formula here. And the notation for it is going to be this t vector for tangent vector. So we find the derivative of the actual vector, and we divide by the magnitude of that derivative. Right, so again, where the derivative in calculus 1 is the slope of the tangent line, this is a similar method to what that's happening there. All right, so let's see if we can do problem number 55 here. So it wants a unit tangent vector for the following curve. So we're given this curve here, 6 cosine 3t and 3 sine of 4t. And this is our r. So we need to solve for the derivative. So r prime of t, we just take the derivative of each of these points individually, for each component. Derivative of 6 is 0. Derivative of this cosine of 3t, well, derivative of cosine is negative sine, but we also have to use a chain rule here. Derivative of cosine of 3t is really negative 3 cosine of 3t. Remember the chain rule. And here we have a derivative of sine is cosine, so it's going to be 3 times 4 is 12 cosine of 4t. So that's our r prime, and to find this t, this is r prime of t, which we have there, over the magnitude of said r prime. So we have r prime right here. And the magnitude, well, first one's 0, so there's no issue there. That's all squared. And finally, this one. Hold on. One of these should be a sine, one of these should be a cosine. So I've made a mistake. This and this and this, these should all be sine. I apologize. Derivative of cosine is sine. All right, and this one's still cosine. And that's all squared. So one more step to, I guess, clean up the bottom a little bit. All right, so that's all our numerator, our denominator. Square all that. And that's a little cleaner. Again, that what we have in the denominator is going to be a number once we insert a t. And we have the 3, so that'll be our scalar essentially, depending on what t is. And our numerator will be a vector.